Right, so when we multiply by the conjugate, our conjugate's going to be the same two terms, root 3 and 2, opposite sign between, so a minus. So when we multiply across the top, just leave it as separate factors. In the bottom, again, if you're thinking of these two being multiplied, the outer and inner products cancel, so I'm left with root 3 times root 3, which is just 3, always a minus here. And then 2 times negative 2 is negative 4. And so 3 minus 4 gives me a negative 1 here. The negative gets moved up to the numerator, and so here would be my solution, negative 4 times the quantity root 3 minus 2. Once again, if you distribute the negative 4, you're okay, but you don't need to do that, so you might as well just leave it as it is. All right, let me go ahead and talk through this next one. Again, the process is no different. Here you have two radical terms in your denominator. So when you rationalize, you're going to use the same terms, root 2 and root 3, opposite sign between, so a negative. Multiply across the top, it stays exactly as it is. And across the bottom, when you multiply these, again, the outer and inner products will cancel. And what you wind up with is root 2 times root 2, which is just 2, always a minus. Root 3 times root 3, which is a 3. You wind up with, similar to up there, a negative 1 overall. Move the negative up to the numerator, and that gives you, once again, your solution. When you're working with this fraction, again, you see it's a double term with a radical, so you need to rationalize. You're going to use the same terms, 3 root 5 and 5. Opposite sign between, there was a plus, so my opposite sign is a negative. So across the top, just leave it as it is. You don't need to do anything else to that, just leave it as factors. But when you multiply across the denominator, the mistake tends to happen with how do you manage these values? Well, when you take 3 root 5 and you square it, you have to square both parts of this number. So 3 squared is 9. Root 5 squared is 5. So really what you wind up with is 9 times 5, or 45. And then always a minus. And then 5 squared is 25. And so if you simplify what you have right here, so I leave my numerator as it is, I have 45 minus 25. That reduces to, or combines to, 20. And then I can look to cancel. I have a factor of 4 and a factor of 20. 4 goes into 4 once, into 25 times. And so here's my simplified form. My numerator, I have 3 root 5 minus 5. And then I divide by my denominator is 5. And that would be my simplified form. So when you are looking to simplify in this form, it becomes the rules that we used for the first half of this section, which was you multiply the top and bottom, or simplify your radical first. Root 10, there's no perfect square factors to remove from that. So when I rationalize, I'm going to use the same radical, the same base, build up my powers. For square roots, it's always going to build up as a 1. And notice I don't need the 4, right? If I put the 4 here and here, those would just cancel out anyway, so I don't need to have those. So when I write my answer, I have root 2 minus 5 all times root 10, all over 4 times root 10 times root 10. Again, the root power cancel. It's root 10 squared, leaving just the base 10. Now, when I rewrite these, what I would tend to do is I would write my, if I have multiple factors, I would write my monomial factors first, then binomial factors, then trinomial, sort of in the order of the priority would be the number of terms. So I'm going to write my root 10 first, and then root 2 minus 5, my binomial. Then I'm going to divide that all by 40. Okay? And so this would give you the simplified form where there's no radicals in the denominator.